What's up, you freaking geniuses? So in this video, I'm going to teach you how to find angle measures in regular polygons. All right, so we're going to cover some key concepts like finding central angles, interior angles, and apothems. All right, so let's go over this example. So this one just says, find the given angle measure for the regular octagon. So we have to find all these different angle measures off this octagon. So you can see we have our 8 sides and we have a few different line segments drawn in here, all right? So let's start with the first angle measure. So we want to find first GJH, right? So that's going to be GJH. So this is the angle measure that we're looking for. Okay, now one thing that you might notice about this angle is that the legs right here hit the corners of the regular polygon. So when that happens, this is called a central angle. All right, I can draw another one over here, right? So let's take these two edges or corners of the regular polygon and we'll draw a straight line from the center to there and to there. Okay, so this right here is a central angle also. And we could draw a bunch of them, right? We could draw another line to here, and then you can see these two legs are hitting these two edges. So this is another central angle. All right, so we can go all the way around and draw all these central angles, but I think you get the gist of it. So since we have a central angle right here, we can use a formula to find that. So it's just going to be that a central angle in a regular polygon is going to be equal to 360 divided by n, where n stands for the number of sides of the regular polygon. All right, so then here, the central angle is going to be equal to 360 divided by 8, right? Because we have 8 sides in our regular polygon. All right, so 360 divided by 8 is equal to 45. So this angle right here is equal to, I'll just write it over here, 45 degrees. All right, let's find the next angle. So next we want to find angle GJK. All right, so that's going to be, it looks like this angle right here, right? GJK. So this angle right here, this green angle. So how can we find this green angle? Well, one thing that you might notice is we have this line right here. So this is kind of a special line segment. All right, this is known as an apothem. And I'll write that up here just because I think it'll be helpful to see it. So an apothem is just a line segment or a distance that goes from the center of your polygon to the midpoint of one of the sides. And specifically, it creates this perpendicular angle with the side of the polygon. Okay, this line segment, the apothem, is basically the same thing as the height of your triangle or the altitude of the triangle. So if we know that this apothem hits this line segment right here at the midpoint, that means this distance is the same as this distance. So that means this green angle is the same as this little red angle. Okay, so if we know that this whole distance, this whole angle is again 45 degrees, well, half of 45 is 22.5, right? So that means this one up here is 22.5 degrees, and it also means that this little green one right here is also 22.5 degrees. All right, so the measure of GJK is equal to 22.5 degrees. Now the next one that we want to find is KGJ. So KGJ. So we already know that this is a right angle, so we know that this is a 90-degree angle. And then we just found this one in the last problem, right? This is 22.5 degrees. And so to find this last angle, we could take the fact that, well, we have a little right triangle right here, right? And remember, whenever you add up all the angles inside of any triangle, they should add up to 180 degrees. So 22.5 plus 90 plus this angle should add up to 180, right? So 90 plus 22.5 plus, we'll just call it angle G, is equal to 180. All right, so it looks like angle G over here is going to be equal to 67.5 degrees. All right, so that's the measure of this angle right here. So let's go to these last two right here. So next we want to find EJH. So next we want to find EJH, right? So we want to find this big angle right here. Okay, well, to find this big angle, maybe it'd be helpful if I just drew a line segment from the center of the polygon to this edge right here. So now you can see that we have a central angle right here. And remember, each of these central angles were equal to, I'll just write it over here, 45 degrees, right? So this is 45 degrees right here. But we also have another central angle right here. And we also have a third central angle right here. So we have 3 central angles, and each of them is 45 degrees. So we could say 3 times 45, and that's equal to 135 degrees, right? So that's the measure of this full angle right here. So lastly, we want to find angle GFE. So GFE, so this angle right here. So this is what's known as an interior angle of the regular polygon. And we have as many interior angles as we do sides. So since we have 8 sides to this regular polygon, we have 8 interior angles. So this is 1, this is 2, 3, 4, 5, 6, 7, and 8. All right, and they're all equal to each other. So how do you find these interior angles? Well, there's a formula that you can use, and it's just going to be that an interior angle of a regular polygon is going to be equal to n minus 2 times 180 all over n, where n, again, stands for the number of sides of your polygon, all right? So if we want to find the measure of one of these interior angles, we're going to plug in an 8 for these ends right here. So here on top, we're going to get 8 minus 2 times 180, and that's over 8. So then on top, we're going to get 6 times 180 all over 8. And then if you plug that into your calculator, we'll get that this is equal to 135 degrees. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.